All right, ladies and gentlemen, when we're solving an equation like this, which again, this is called an exponential equation, very much like the previous video, we don't have to check answers. What we do look for when you're solving an exponential equation is you look for a common base to start with. Well, this is pretty easy here. 3 to the 2x minus 5 power is about as simple as we're going to get on this side. But when I look over here, let's see, 81, 3 times 3 times 3 times 3, there we go. 81 is 3 to the 4th power. 9 times 9, which breaks down to 3 to, yep. 81 is 3 to the 4th power. Whenever you're solving an exponential equation and you make the bases the same, at this point you virtually ignore them. The only way this can happen is if the powers are equal. So your very next line here would be to ignore the bases and to equate the powers. That would give me 2x is equal to 9. X is equal to 9 over 2. And we're done. Okay, now, here's an example where you can't get a common base. Okay, obviously this is Euler's number. This is 934. Good luck trying to get a common base. That's not going to happen. So let me write the problem a little bigger. Now, the way I've taught you to do this in class, this is like a cat trapped up a tree. You need to go get a ladder. You have a choice of 2 ladders. You can either get a natural log ladder or a common log ladder out of the garage. However, there's really not a choice here. There's a better choice here is how I should put it. Whenever you see Euler's function, make your life easier, go get the natural log ladder because they're inverses of each other. So when you compose them, i.e. when you use them together, one cancels the other out. So, when I get the natural log ladder, it affects both sides, okay? If these two numbers are equal, then when I put them both into the natural log function, I will get equal answers, okay? I've heard teachers in the past say, take the natural log of both sides. That kind of gives me the creeps, actually, because what we're really doing, I mean, I guess that's what we're doing ultimately, but I want you to understand what we're doing. If 2 numbers are equal, then when I put them in the natural log function, their answers will come out to be equal, okay? So we just fed them both into the, since they were equal to start with, when we plug them into the same function, we get equal answers. Now, over here, look what happens. The natural log is really log base e. E, we come in contact with Euler's function. This function cancels out this function, just leaving me with t. Done, okay? And it's equal to the natural log of 934. Now, if you were asked, let's say on the final exam or in some future course, to give this answer to the nearest thousandth or whatever degree of accuracy your instructor wanted, then you simply go to your calculator, push natural log 934. I usually close the paren just because I'm obsessive about parens. So I would put in the right paren. It already gave you the left paren. And then I would hit enter. And then I would give the answer to whatever degree of accuracy you were instructed. But notice my instructions here just said solve for t, okay? It didn't say approximate it. So I'm leaving my answer like this. But you've been taught the calculator skills to know how to go that one step further if you're required to. And we're done.